Hello again, everyone, and welcome to today's webinar. My name is Geneva Langland, and I work with Michigan Sea Grant based in Ann Arbor, Michigan. I'm one of Michigan Sea Grant's representatives on the Great Lakes Sea Grant Crude Oil Transport Team, which includes Sea Grant programs from Minnesota in the west to New York and Vermont in the east. I am going to stop my screen share right now so you can see me as I introduce the webinar and Mark Malkoff on the other screen, who is going to be presenting today. So welcome to our first webinar of 2020. The Crude Oil Transport webinar series is meant to provide the latest research and resources to stakeholders in the Great Lakes region to inform decision-making around this complicated and complex issue. Anyone with a vested interest in how crude oil and its associated products move throughout the region should find the content of this webinar informative. Here are just a few logistics before we begin. This webinar is being recorded and is also live on Facebook to anyone who's joining us through that platform. The webinar recording will be available with captions up on the Crude Oil Transport website, which is glslcrudeoiltransport.org, or it'll also be up on Michigan Sea Grant's YouTube channel within a few days. Attendees are invited to submit questions or comments or technical challenges through the question and answer box using the little icon down in your Zoom toolbar. Feel free to submit your questions throughout the presentation at any time. We'll be collecting those for the Q&A session at the end of the presentation. And last but not least, remember to join us next month on July 22 at 10:30 a.m. Eastern to hear our second webinar, which will be presented by Kristen Lewis at the U.S. Department of Transportation's Volpe Center. She'll be presenting about conceptualizing risk-based hazardous material routing tools. So make sure to register for that. The link is available on the same website where you registered for this, and be sure to join us. So with all of that now said, it is my pleasure to introduce today's speaker, Mark Malkoff. Mark is an adjunct faculty member at the Plattsburgh State University of New York, where he has served as an aquatic resource specialist with Lake Champlain Sea Grant since 1999. His research and extension interests have included bass tournament sustainability, Champlain Canal invasive species barriers, stakeholder responses to flooding, and crude oil transport, which is why he's here to talk to us today. His career with Sea Grant has spanned nearly 34 years, including 2 stints with New York Sea Grant on both Great Lakes and marine coasts. Mark's personal interests include sea kayaking, backcountry skiing, Nordic skating, whitewater kayaking, bicycling, and fishing, which makes me exhausted just thinking about all of the exciting things he must be doing outdoors. This year, his adventurous streak has already taken him on a kayaking trip through the Grand Canyon, and this December, he'll embark on a totally different journey as he retires from his position with Lake Champlain Sea Grant. So Mark is here today to tell us about ramping up and ramping down crude oil rail shipments and community responses from 2015 to present from a Lake Champlain perspective. So go ahead, take it away, Mark.
Good morning. Hopefully everyone can now see my title slide.
Looks great, Mark, thank you. And
I just would kind of start this off by noting that I'm not an oil spill response expert. I'm not a geographer. I'm not a chemist, but I am a pretty good observer of community issues relative to aquatic resources, and I've hung around a lot of smart people talking about crude oil transport since about 2014. So we'll see if I can tell a good story today. In terms of an outline, oh boy. My approach today, I'm going to just kind of describe the situation in both the Great Lakes and Lake Champlain, starting around 2013 up to present. And I'll review a few reactions, mostly in the Lake Champlain watershed. We'll talk about responses, community responses, and others by government stakeholders and obviously Sea Grant. Try to touch on a few outputs and outcomes, and then I'm going to wave my arms a little bit and look into my crystal ball and make some predictions about what the future might hold relative to crude oil transport on rail. So this idea of moving oil by rail cars is not new, but things really got rolling, no pun intended, around 2013, 2014, when a formation of oil-bearing shale in North Dakota, known as the Bakken Formation, started to be exploited in response to increasing demand for petroleum products in the U.S. and worldwide. And it was really enabled by a couple of technologies. One was fracking, where you disturb underlying strata historically by explosives and more recently by fluids, and combine that with horizontal drilling to facilitate people getting access to these resources. And that's what really drove this phenomenon that's shown here in terms of the increase of North Dakota field production. I thought people might be interested in actually seeing what Bakken crude oil in a rail car looks like. Here's a short video. Sorry for the wind noise. I didn't get the volume turned down in time, but the point was to show you that there's effervescence going on here. There's this light crude oil has got a lot of entrained dissolved gases like butane, hexane, propane, and it's a flammable mix for sure. And a lot of it was going through New York State and continued until fairly recently along a couple of rail lines. In every rail line obviously is in somebody's watershed, and there's a lot of other infrastructure in those watersheds that are of interest to people in terms of protecting against either natural or man-made disasters. And this phenomenon got the attention of the governor's office in New York, and he directed a lot of state agencies to do a little fact-finding on this phenomenon and that they reported out in 2014. Oh, and I would point out, sorry to go backwards, that at the time of this report, it was estimated that 3/4 of all of the Bakken crude oil production that was moving on rail was traveling through New York on its way to refineries in New Jersey or refineries elsewhere. We can't really get our hands on oil transit data on railroads in a specific fashion, but we can get generalized information that's aggregated by the U.S. Energy Information Agency, and they break it out by these PADs, or Petroleum Administration for Defense District maps. So I'm going to present some generalized data from these sources of information. And again, I'm using this stuff as sort of a proxy for what's going through New York. We can't get specific data, but we recognize that most of the East Coast refinery capacity was downstream of New York. It makes for a reasonable assumption to track what's going on in New York by tracking what's going on between PAD Districts 2 and PAD Districts 1. Excuse me. So East Coast receipts by rail from the Midwest, 2010 to 2019. You can see this huge ramp up and spike along about 2014 or 2015 when we're moving some 13 or 14,000 barrels of oil from the Midwest to the East. And then a huge fall off in 2017 and 2018, a bit of a recovery in 2019. Similar pattern for oil that's coming to the east coast of the U.S. by rail from Canada. Again, a huge drop off in 16 and 17 as prices fell worldwide, and then a bit of a ramp up again in 18 and 19. Meanwhile, if we look at pipeline transits from the Midwest to the Gulf Coast, things were on a major increase throughout the period of 2010 to very recently, early in 2020. And I've kind of hypothesized, and I still can't prove it, that our decline in crude oil movements by rail here in the East is taking place because of increased pipeline capacity in the Midwest and central part of the country. And here's a composite graph of a bunch of these transits across a bunch of these regions, and you can see again the dominant pattern was a lot of movement of oil from the Midwest in 2014, 2015, falling off after that. In the increasing amount of oil coming from Canada to the U.S., especially in recent years. So moving a lot of oil by rail, what's the big deal? Well, fire that consumed a big chunk of Lac Mégantic on July 6, 2013 was ignited by a derailment phenomenon of rail cars carrying Bakken crude oil, got a lot of people's attention. And there were some other accidents on the East Coast and throughout North America that was getting the attention of the media during this period. And I would point out that single tank car has got a capacity of about 30,000 gallons. So there's something to be watching there. And these tank cars might also be carrying things like propane, refined fuel, and other fuels. And in the case of Lake Champlain, we were especially interested because we've got about 120 miles of lakeshore, most of which is paralleled by a rail line owned by CP Rail, moving product from Montreal to New York City. Currently, we've gone from a huge amount of oil moving on that line to apparently almost none, although we can't get written confirmation of that. We're pretty sure that the crude oil is no longer moving in significant quantities on this rail line. And these tank cars can carry lots of stuff. So just because you see a tank car going down the rail line doesn't necessarily tell you what's in it. In addition to petroleum, there's things like alcohol, sodium hydroxide, sulfuric acid, propane, diesel fuel, and you name it, that's moving in these regulated cars. And non-regulated commodities are essentially in the same type of car, and it's pretty hard to tell what's going by. Nothing particularly hazardous here unless it's too much corn syrup in the American diet, I guess. It's maybe gotten a bad rep. So the conditions locally in 2015 were, again, that there was large amounts of fuel crude oil being transported along the Lake Champlain corridor. If you do a little arithmetic, it looks like there was about 750 million gallons of flammable cargo tooling along the Lake Champlain shoreline every week in the spring of 2015. And people were starting to ask questions and express concerns about safety, health impacts, potential environmental impacts, and you name it. So in response to that, a local environmental advocacy organization put together a forum and asked the local county Office of Management emergency services to speak, along with some EPA folks. And I was asked to talk a little bit about potential fishery impacts of this cargo in a spill situation. And that was kind of the first response we'd seen relative to this phenomenon. Another response came on the part of New York State. I mentioned the governor's office was looking very closely at this situation, and shortly after, the New York State Department of Environmental Conservation embarked on the development of geographic response plans. And I'm stealing a few slides from Tom Festa, who at the time was the spill coordinator for DEC. These GRPs were modeled on Coast Guard environmental sensitivity indices, but the effort here was to put more effort on how to protect a particular resource rather than where it is or mapping it out. And here's an example of one of those GRP products. Here's a map of downtown Plattsburgh, New York. And it's just putting out up here as a sample. The yellow lines define a corridor of about 1,000 feet from the rail line. And it encompasses things like schools, hospitals, gas stations, water intakes, senior living, you name it. But all things that we want to be paying attention to in the event of a spill. And the orange, so the yellow corridor denotes a 1,000-foot corridor would be directly impacted by spill. The orange lines define a corridor that would be potentially impacted by fire. And that's a half mile away. And the back of these cards provide basically a phone list. Who do you call? What do you tell them? And what kind of information, what kind of resources can you bring to a spill? And these GRP plans were developed for every county, in New York, which had one of these rail lines going through it. And this information continues to be available. Excuse me. They also were able to compile foam caches, firefighting foam caches along these rail lines in New York. And currently these caches are still available to both state fire agency folks and local county emergency management people. They've got foam caches within 2 hours or less of every major rail line in the state. And now I guess one concern that people have now is the firefighting foams contain PFOS and PFOAs, which have been implicated in some human health and water quality issues, but we'll save that discussion for another day. In addition to the geographic response plans, EPA began development of shoreline response guides, which were similar, involved a lot of ground truthing along Lake Champlain. And I was invited to participate in some of this effort. And just as a follow-up, I was able to provide a contractor with some information that proved useful, I think, in the development of these response guides. And here's a few photographs of those surveys taking place, just boat rides to see what's what and map it out and take some notes on where you might be able to get spill cleanup equipment to the problem and where you can't. You can see some of the shoreline of Lake Champlain is not very accessible by road. These rail lines, again, are very close to the water, stone's throw away from deep water sites and wetlands both. So it kind of underscored the need to do this kind of planning. In terms of responses, the industry itself has had a couple of training events here in Plattsburgh, and I would credit CP Rail with providing these opportunities to local first responders, and I was able to participate in one in winter of 2018. That's me on the lower left practicing getting out of cold water and in the event that you fall through when you're trying to work on an oil spill. There's some advantages and disadvantages to trying to recover oil underneath ice, and I could go on for hours about that. But there's some tricks of the trade that have been developed by oil spill response corporations, and the folks at CP Rail are very interested in having as many local folks learn some of these tricks as possible. In addition to state and private industry responses, not surprisingly, there was some legislative movement. I know Senator Schumer was interested in modernizing some of the regulations dealing with tank car regulations and the fuels and the hazardous materials being transported on tank cars. I'm not sure what the status of that legislation was at the federal level. I think there's been some change on the part of agencies, but I'm not sure if what happened legislatively. And some of these training exercises continue as recently as last fall. EPA and the Coast Guard, local fire departments, state fire agencies all got together in New York DEC to hold a joint response exercise in Port Henry, New York. There were classroom sessions and outdoor sessions on how to deploy boom and whose boom can connect to somebody else's boom, and it was good to see who's going to be able to do what, bring what sort of resources to bear in the event of a spill. Again, pretty heavy involvement by the rail industry. That's Clem Shimakowski on the bottom right, talking about some of the resources that the railroad folks could bring to bear in the event of an accident. So changing scope a little bit, this crude oil movement team that largely populated by Great Lakes Sea Grant folks that Geneva mentioned, kind of got up and running with a conference in Racine, Wisconsin in April of 2015, just to, as a start, try to examine some of the key issues around crude oil transport, not just by rail, but all modes of transportation. And a lot of people were brought to the table, industry, NGOs, Sea Grant, agency people, to try to develop some understanding of what we're really up against here, what we're looking at. And later that year, a smaller group of folks involving Great Lakes Sea Grant and the crude oil movement folks got together to develop a research agenda at a meeting in Chicago. Excuse me. Some of the outreach education efforts of this crude oil movement team continued into 2016, 2017, and continues today. But we started doing webinars in 2016, took kind of a deep dive into the issue in 2017 with a symposium in Cleveland, Ohio. And I would mention the proceedings from this symposium are online and available to people if you're interested in it. Well, it's worth taking a look at. There was some really good information that came out during that event. Some of the takeaways from that event, my focus is really on railroads because we're moving product next to Lake Champlain, but in the grand scheme of things, rail transport is a very minor issue relative to pipeline in the Great Lakes basin. Most of the crude oil moving through the Great Lakes, greater than 90% of it's moving by pipeline, not by rail. But still, at times, significant portions can move locally with potential impacts by rail. And I want to thank Brad Hull for a few slides that I've stolen here from the 2017 symposium. He mapped out refinery capacity in the Great Lakes to point out that it's only about 20% of the refinery capacity for North America is located in the Great Lakes. But I've added a couple of dots here that are important from a New York State standpoint. This purple circle is I added to New Jersey because a couple of refineries in New Jersey were the destination for most of the oil moving through New York by rail. And some of that oil was actually put aboard ship and taken to St. John, New Brunswick for refining. The refinery in St. Brunswick is the largest refinery in Canada, and it was an interesting way to get oil to that site. So again, one point it was leaving North Dakota by rail, going to Albany, New York, or New York City, and then being loaded on tankers to go to New Brunswick, where it was refined, and 75% of it gets brought back to the U.S. for consumption. Some lessons and takeaways from that 2017 symposium relative to oil spills. Here's a slide I stole from Doug Helton. These oil spill events are high impact but rare, so that means there's going to be sort of a relearning every time because of agency personnel change, changes in procedures, changes in technology. There's going to be always plenty of need for science. Early information is probably going to be revised. Residual oil is extremely difficult to recover. There's always a need for plume and spill modeling, and not surprising to folks like myself, outreach and extension are going to be important components of any spill response. I should mention that the whole idea of response is nothing new in terms of our symposium. The National Contingency Plan system was put together by congressional effort back in the late 60s, early 70s, I believe, in response to a huge oil spill in the United Kingdom. But it was really an effort to force agency cooperation when it came to spill response. And there's lots of contingency plans out there that are available to folks that are doing planning. And I would, given the events of the last few weeks in the U.S., I would want to make a shout out here to John Francis, who boycotted transportation for 22 years following an oil spill in San Francisco Bay. Then he was motivated enough to pursue a PhD focusing on oil spill impacts when very few people were studying oil spill. And I've yet to read his book, Planet Walker, but plan to do it this year. Some other takeaways from the 2017 symposium is that there's lots of not only environmental but social impacts of man-made disasters like oil spills. Man-made disasters tend to be different than natural disasters in that there's more uncertainty, kind of an unknown timeline, compared to hurricanes or earthquakes, and it can have a much different impact on the community in terms of community resilience. And there's a lot of social science that has come out of this work that's available to people for planning purposes. Coming back to Lake Champlain, in terms of response, I want to mention some work done by Jason Scott. He recently completed a master's thesis on the development of a scientific support network relative to oil spills in Lake Champlain. And I'll whip through a few of his slides here. Spills along Lake Champlain are not unknown. They are pretty rare. We've not had a crude oil spill, but there have been things like diesel fuel, cement, canola oil, gasoline spilled in the lake before. So it's not an entirely new phenomenon, but the size of what we were dealing with in the late 2000s suggests that there's always room for more. So the kind of the take-home message from Jason's work is that a scientific and academic resource network is be really useful for environmental disasters on Lake Champlain. It basically consists of a database available to federal and state agency folks. Not a whole lot of requirements for personnel resources listed in the database, but they can be mobilized to provide valuable scientific information and expertise following the spill. And it's a database. You can look people up by name, or you can look up folks by subject area expertise and pull this stuff together. So a little metadata about the network. He was able to identify 31 people with some expertise, 4 facilities, a few research vessels, and some organizations that could all be brought to bear in the case of a spill response. I guess I kind of glossed over the need for this sort of thing. It grew out of a situation in Rhode Island following an oil spill where the responsible party quickly got in touch with a lot of academics and university people and actually hired them to do work relative to spill response. But those data and information that they learned were then contractually obligated, and they weren't available to the public or government agencies doing spill response. And kind of the take-home lesson for that is that if we've got a scientific support network that can be mobilized, a lot of that information will remain in the public domain, and everybody can put it to good use in the way of spill response. And moving forward, there's plans to make this website, or keep this website up to date and provide training on it and coordination with the response agencies and exercises. So we've had a phenomenon, we've seen responses, we've done some training. What's the future hold? I have no idea, but surprises are certainly in store. One, I guess as we look back a few weeks now, it shouldn't be that much of a surprise, but oil consumption dropped drastically along in late March, early April, as we entered a kind of a nationwide shutdown of the economy. I'm sure, almost nobody saw this coming, at least in the energy industry, but things like this can really take our understanding of crude oil transport movements and kind of tip things upside down. In terms of future trends, I'm going to go way out on a limb here and predict that oil prices are going to be someplace between $85 and $10 a barrel next year. At the high end of that, I think you're going to see continued exploration, production, transport of crude product. If we're down in the lower end of that stuff, we're approaching the place where you're paying people to take crude oil off your hands. So somewhere in the middle there, I expect we're going to see things kind of return to what we've seen in the late 2000 or late 20 teens, but all bets are off, I guess, is what I'm trying to say. I'm kind of curious as to what would happen with increased production demand for crude oil products on the East Coast. But one thing I was able to pull up, it's the two states with most of the refining capacity on the East Coast are New Jersey and Pennsylvania. New Jersey has gone from 6 operational refineries back in the 80s to 2 or 3, I guess it's 2 refineries at present time. I think Pennsylvania is down to 4. West Virginia is at 1. I don't see a huge potential for increasing refinery capacity on the East Coast. So I wouldn't think that we're going to see anything higher in the way of crude oil transport than what we saw in 2014, 2015 in New York. But as refining the refining capacity in the Gulf Coast vastly dwarfs that on the East Coast, the whole emphasis was new pipeline development in the center part of North America is meant to get product to the Gulf Coast refineries, and I don't expect that pattern to change. Kind of leading up to that, I've stolen some more slides from Brad Hull from a couple of years ago here. Excuse me, he mentioned 3 projects with potential impacts on Great Lakes crude oil transport. One of them was a proposed Energy East pipeline in Canada. That's been canceled. The Dakota Access pipeline was completed shortly after President Trump was inaugurated, I believe. That is, I'm sure, taken a lot of the pressure off crude oil transport by rail and shifted that production into pipeline so the product can move from North Dakota towards Texas, Louisiana, for example. I'm not sure of the status of the Trans Mountain pipeline in Western Canada, but I believe that continues to operate and has undergone some upgrades and expansions, and that's how a lot of Western Canadian oil is being brought to market. And I just stumbled across an opinion piece in my local newspaper a few weeks ago that I captured here in the bottom left, that there's some strange bedfellows when it comes to pipeline completion and pipeline projects in North America. There's some folks both north of the border and south of the Canadian border that are quite interested in having the Keystone XL project completed, but obviously the completion or non-completion of that pipeline would have a lot of implications for crude oil transport by rail. Again, a lot of production from Canada, and I guess that's expected to increase in the future. The experts are forecasting some kind of a rebound to normal world production and world consumption, although production is going to lag behind for a while because there's a lot of crude oil product and refined crude oil product that's available for consumption already. I don't know what's going to happen in North Dakota with Bakken oil. Some of the estimates I've read is that it's profitable to do this fracking and horizontal drilling when world oil prices are $75 a barrel or higher. When it's below 75 or below $60 a barrel or below $40 a barrel or whatever it is now, a lot of this production just falls off. People get laid off, companies go out of business. It's just cheaper. It's not cost effective to get the stuff out of the ground, and the decisions are made to leave it in the ground. So depending on what prices do in the future, you can expect to see either more or less production out of this Bakken formation in North Dakota. I've kind of glossed over tank car anatomy. Should mention that before I get done. A lot of the reasons people were pretty scared and interested and excited about crude oil transport by rail is that most of the transport was being done in DOT 111 cars, which I don't have a good diagram or list of things that DOT 111 cars have. But if you look at the bottom left, all the things that a 117 car has, a 111 car doesn't have. So for example, 111 cars don't have prominent head shields at both ends of the cars. Some of them have half height shields, some of them have no shields at all. Tank shell thickness is less than 9/16 inch minimum. There's no thermal protection. There's thin gauge jackets. There's no top fitting protection, and there's no enhanced bottom outlet handle designed to prevent unintended actuation during a train accident. So a lot of effort has been made to either get DOTs out of use or get them beefed up so that they're better able to handle the shock and impact of derailments. So some good news associated with that is the fact that DOT 111 cars are kind of being removed from the fleet. One of the fixes was to bring DOT 111 cars up to CPC 1232 standards, which is just a beefed up 111 car to make it safer, more robust. But even those CPC 1232 cars are being phased out, as you can see in the stacked bar graphs here. And the good news is that the fleet is becoming more and more dominated by these DOT 111 cars, which are more robust, safer, better able to handle derailments, more resistant to rupture in the case of derailment. There is still a lot of DOT cars moving ethanol, but similar pattern, they are being phased out. Brief transition to CPC 1232 cars, but the coming model will be DOT 111 cars in both Canada and the US. Again, kind of waving my arms here. I don't know what's going to happen to global energy and investment in the future. There's some headlines that suggest a 400 billion drop in 2020. We'll see. But that drop can manifest itself in lots of ways, including bankruptcy for some of these energy firms, including Chesapeake Energy. They were one of the first groups to really capitalize on the technology associated with shale oil, and but looks like they're going away. So at that point, I guess I'll wrap up. I've probably been yammering for about 45 minutes here. I would put a shout out to our web page that has a lot of resources if people want to delve into this a little bit more. As I mentioned, we've got proceedings from our 2017 symposium in Cleveland. We've got archived webinars from 2016, 2018, and I believe this year's webinars will be archived on the site too. There's an extensive library. There's some issue overviews, lots of good resources on this webpage. And I would urge people to take advantage of it if they're interested in this topic. And I would be remiss if I didn't mention a lot of the folks that have been involved from this effort from day one. Our crude team, first iteration, if you will, is made up by the list of folks you see here. Excuse me. I particularly want to mention Dale Bergeron, Kathy Bunting, who were instrumental in getting this group up and going in the Great Lakes. And I've learned a lot thanks to their efforts. And I think Kathy Bunting would be the first to admit that she learned a lot from Susan Christopherson, who passed away in 2016. Susan was a very bright environmental planner, geographer at Cornell University, who was one of the first people to acknowledge or learn about this crude oil transport by rail in New York and bring it to the attention of elected officials, including the governor's office, and that we've learned a lot thanks to her efforts. And the current makeup of this team is some folks that you're probably already familiar with, but want to thank Geneva Langland for riding herd on me today, and all the other folks that are contributing to this effort. And at this point, I guess I'll stop. I haven't looked at my chat box, but I think we're going to have time for some questions if I'm correct.
Yep, and this is Geneva jumping back in. Thank you so much, Mark, for that really excellent presentation. I am going to come back on video, but if we run into any questions that require you popping your PowerPoint back up and flipping back to your previous slide, we can always do that. So we do have some questions here from our audience. One person is wondering, if we see a rail car, can we use the codes on the outside of the car to tell what the contents would be?
I think so. If I'm correct, the hazmat code for crude oil is 1267. So if you see that on the hazmat placard, it should have crude oil in it. Trouble is, when the tank cars are going by your local crossing at 40 miles an hour and there's 100 of them in a row, it's a little hard to tell what's on those placards. But if the car's not moving, those placards do indicate the contents, and you can get online and look up those placard numbers. Just Google them, and you can, under hazmat codes, and you can get some idea what's in the car.
Okay, good way to satisfy curiosity. All right, so we've got a few other questions, and a comment from John Lipscomb with the Hudson Riverkeeper. He said that at peak they had 2 trains and a barge bringing 4 million gallons each per day on the Hudson River. And now there's only trains running down the Mohawk and Hudson River shoreline. So we can see sort of that shift away from needing all that capacity.
Yep.
Let's see, we've got a question about what spill response looks like by land or by sea, you might say. So what does spill response look like in places where road access is difficult or non-existent? Are there usually, and I'll say that this is specifically for Lake Champlain, is there a robust enough vessel response to get to those sorts of locations?
Give a nice waffling answer. That depends. There's not a lot of commercial barges that would be available to assist with something like that. As I learned from that last exercise we had, was held in September, if most of the rail line is still intact, and chances are it will be, the rail line itself could provide access to heavy equipment up very close to the site of the derailment. So that's some resources that can be brought to bear. But other than that, it could be roads. You're not going to have barges in large enough number or large enough capacity to bring in a lot of heavy equipment, at least not without a lot of effort. So that's a concern.
Sure. We have one person wondering about the level of reporting, or I guess the level of data availability for crude oil transport. Is it hard to get your hands on tracking data and other information about crude oil transport?
If it's being transported by rail, yes. And if you're looking for specifics, yes, you can get this generalized data that I presented. But if you want to know how many trains or how many gallons on a given date, that's proprietary information. Some of the folks are able to get a good estimate of that, like one of the people that just posted from the Hudson Valley. But emergency responders, I think, can get their hands on that information, but it is proprietary, and sometimes there's Homeland Security issues associated with that. So I haven't found an easy way to find out whose train's coming down tomorrow with how many gallons of fuel or crude oil on it.
Sure. I can see the companies being pretty hesitant to put that information out there. So speaking of the rail carriers and the rail companies, what sorts of liability or limits to liability do those companies carry when it comes to environmental cleanup or damage from spills?
Oh, I should be able to respond to that better, but they they are heavily insured, and the insurance companies really are in the driver's seat on a lot of this stuff, because they they're the ones that are going to have to deal with the eventual cost of cleanup. But there are federal programs that step in to provide the initial cleanup, and then worry about the money later. That's, oh man, probably some folks on the call could better provide the name of that legislation, but CERCLA comes to mind. There's programs that where the government will come in, do oversee the execution of the cleanup, and then we'll worry about who pays for what later.
Right. Another question here about spill response in rivers, tidal systems, estuaries, other places where water is constantly moving in ways that is really hard to trap it and keep it one place to do that cleanup. What does response look like for the Mohawk River, the Hudson River, places where a boom that's meant to just keep the water in place doesn't really do it?
Yeah, I assume these GRPs that I spoke about were developed for the Hudson, lower Hudson also, but one of the reasons they were put together is just to figure out what areas can you protect with a boom and what areas can you not. And there are different types of boom. The boom for inland use is lighter duty and smaller scale than what you'd see in a coastal area. But if you get there soon enough with enough boom and the weather is in your favor, you can actually do a reasonable job of protecting, either booming oil away from sensitive areas or booming to collect oil for recovery. If you get there quick enough with enough equipment. If you've got adverse weather, ice, stormy weather, big waves, sensitive wetlands, then things can go wrong, from what I've seen. I would point out we've got some of this information archived in previous webinars. I think from 2018 we had some good ones. 2019. That one of them deals with oil recovery in the Great Lakes, and people should take a look at that.
I was going to make the same shout out. Yes, on the glslcrudeoiltransport.org, the webinar page there has 4 webinars from last year that covered a lot of spill response training and tactics, and including a whole webinar about oil recovery. That was, looks like Marcus. Yes, thank you. That's the URL right up there. So if you're curious about some of the presentations that we might have given, you can find them up there. I was really interested to learn about those county by county spill impact cards that you showed us, with the yellow corridors, the orange corridors, all of those icons for the different sensitive locations along a rail line. I just thought those were both the product of a lot of hard work and extremely useful. Do you know if those have been made or adapted for other type of disaster response?
The geographic response plans that New York put together were, I think at the time, they were sort of unique in their detail and comprehensiveness, but they were not totally unique in their existence. Washington State, I think, did something earlier. I probably got something in my notes I could dig up. Some other states have done similar stuff, but that was a pretty detailed effort on the part of New York. These things have been done for coastal areas, but not much in the way inland. in there. Of course, the problem with something like that, as soon as you publish that it becomes out of date. But they are living files that can be updated and made available, as I understand it. So that I think they have a lot of potential good use.
Mhm. So you had mentioned that the yellow corridor and the orange corridor delineate different types of effects that people or structures inside those corridors might experience. You mentioned that the outer corridor could be affected by fire. What sort of impacts might you expect to see in that inner corridor after a spill?
Well, I think, you can just imagine that if there's high density, schools, hospitals, people that might be subject to inhalation of product or, environmental issues with, if you spill 30,000 or 60,000 or 100,000 gallons of crude oil, there's going to be predicted and unpredicted impacts to whatever's in that corridor. But those GRP plans were an attempt to at least identify what's there in how far away is it from the potential spill site.
Mm-hmm. I've got a few more questions from our audience. We also have a few more minutes, so if you have a burning question you'd like to get through, be sure to put that in the Q&A box. So one attendee is wondering about the impact to the Lake Champlain ecosystem if a train were to derail. I know that's sort of a big question because trains can be carrying different types of materials and could be landing in different parts of the Lake Champlain area. But let's say if it's crude oil, what sort of
I can
impacts?
take a stab at that. So in the case of oil spills, we've got a lot to learn when it comes to freshwater. The good news is we don't have a lot of experience. There's been very few major spills in freshwater. That pipeline spill in Michigan, I'm blanking on the name of it, was
yeah, that was the line. Oh no, I'm blanking on it too. Line 2, Enbridge Line 2 in Kalamazoo area.
Yeah, I think there's a lot of information that came out of that, but that was heavy oil, as I understand it. It tends to sink. This crude oil that was being transported by rail through New York is light oil that tends to float, so it's going to behave very differently in the environment. I think the good news is that it is, from an environmental standpoint, it is volatile enough that if there's an explosion, a lot of it's going to burn off. It's not going to do much for air quality or human health if people are nearby, but a lot of it could be removed in the case of explosion and fire. In terms of fishery impacts, it depends on where and when. If there's a lot of early life history stages around in the spring, I would expect a lot of fish mortality in larval stage or the eggs of fish. If it's later in the year and it's mostly adults or juveniles, then there's going to be less impact from oil spills. If it's under the ice, wow, it's going to be there for a while. It's going to be hard to clean up, but it's not going to move very far either. So that I would expect the impact to be more localized. If it's in a wetland, hard to clean up, it's going to be impacts to terrestrial and aquatic stuff. If it's in deep water, in places along Lake Champlain, you can throw a rock into 120 feet of water from the railroad tracks. And if a tank car lands down there but doesn't rupture, what's it going to do? I don't know.
Yeah.
Can you get it out intact? And if so, then the impact would be minimal. If it ruptures in 100 feet of water and it's heavy oil that sinks, that's going to be a problem. If it ruptures and it's light oil that can be boomed and collected, then maybe you can get most of it back, or a lot of it back. I hate to waffle, but it depends.
Yeah.
It's the short answer.
Yeah, we need more research and more information about the impacts, but we don't want to have to learn from experience.
Yeah,
We'd rather be
yeah.
able to learn from theory.
So I see in the chat room somebody is pointing out the Line 6B Kalamazoo
Yes,
River spillage.
yes. Thank you for that refresher, Noah.
Yeah, Mark Breederland, I know in our group, passed along some documents from that event, and at one time the recovery costs were about comparable or maybe even larger than the Deepwater Horizon spill in the Gulf of
Wow.
Mexico.
Yeah, these are big numbers and big impacts that we're dealing
Yeah.
with here. So it is 11:30, so I think we're going to call it good. Thank you so much to everybody who tuned in today. And remember that this will be recorded, captioned, and available up on the website that Mark is showing us right now at that URL. And we will be reconvening again on July 22nd for another presentation from this group, from Kristen Lewis. So thanks again, everyone. Thank you very much, Mark. This was excellent. And I hope everybody has a great day.
All right. Thank you.